Alright, this is molar conversions of all types. So the first part, we call it the molar roadmap. What I want you guys to do is on your notes, I want you to go ahead and copy this down. It's from grams over to moles. Same thing we did yesterday, but this time I'm going to add in 4 different things. Atoms, ions, units, and molecules. Alright, going from right to left, going from grams, you're going to put 1 mole on top and the molar mass on bottom. Over here you're going to put 6.02 times 10 to the 23rd. Oops. And then you're going to divide that by 1 mole. Alright, now going the other way, I'm going to do this different color. Going the other way, you're going to put 1 mole on top and 6.02 times 10 to the 23rd. And then going from moles to grams, you are going to put the molar mass over 1 mole. So, the reason why I'm having you write this down again and again and again is because on your test, quiz, or any other type of assessment that we give you, we are not going to give you the molar roadmap. And most of the time this is helpful. So the only way to really make sure that you understand it is to copy it down several times. Okay? So, let's talk about this. The reason why there's 4 things over here is that it can be 6.02 times 10 to the 23rd of anything. Could be atoms, ions, units, or molecules. So we're going to go through and we're going to try to figure out what each type of these things would be called. So ionic compounds are called what whenever they're over here? What do you think? Starts with a U. Units. Alright, so ionic compounds are called units. Ca2 plus would be a what? Say again? Ion. Mg just by itself would be a what? Atom. And covalent compound? Molecules. Alright, so that's the answers to the top part. So let's go ahead and let's try an easy problem. We're going to skip ahead to example 2. I want to do this one first because I haven't shown it yet on the videos. What is the number of moles in 139.95 grams of potassium hydroxide? So the way this works, now what we're doing is we are starting in grams and we're going to moles. So we're going to use the top part. It's going to be 1 mole over the molar mass. So for this part, we're going to do 139.95 grams of KOH. We're going to divide that by the molar mass over 1 mole of KOH. Because that is what potassium hydroxide is. So that's 39.1 plus 16 plus 1.01. So this becomes 56.11 grams per mole. Alright, so we stick it in here. So if I say that I have 56.11 grams per mole, that's exactly the same thing as saying, I can flip it around and say 1 mole is equal to 56.11 grams of KOH. And so I chose this one to stick into the equation because my units will cancel out. Grams KOH cancel out, and grams KOH cancel out. So I'm left with moles, which is what my answer is wanting us to look for. So what does my final answer end up being? Well, what I'm going to do is I'm going to multiply by the stuff that's on top, and then I'm going to divide by the stuff that's on bottom. Because anything multiplied by 1 is itself, I don't actually have to multiply this number by 1. So I'm going to do 139.95 divided by 56.11. What do I get as my final answer? 49207? Sorry, I got some bad information. So it's 2.49420. So then I need to round my sig figs. I have 5 in my beginning part, so I'm going to round this to 5 sig figs. So 1, 2, 3, 4, 5. Because this number is 0, I don't have to worry about it. It just goes away. So it's 2.4942. 1, 2, 3, 4, 5. Good. Mole KOH. And that's my final answer. So that's pretty much it for the gram to mole part. So on your homework, it's pretty simple. So let's go ahead and let's look at this part over here with going from grams to molecules. So the way this is going to work is we need to find the formula, find the molar mass. So we're going to find the molar mass of C12H22O11. So I'm going to take 12 and multiply it by 12.01 because that is the what? Of carbon. 22 times 1.01 since it's the molar mass of hydrogen, plus 11 times 16, which is the molar mass of oxygen. If I remember correctly, it should be 343 something is the molar mass. 342 point, one more time, 34 grams per mole. Alright, so then this is what's going to happen. Okay, so I'm going to use 3 lines. Now, this is equivalent to saying if I have 500 centimeters, I want to know how many feet I have. Do I know how many centimeters are in a foot? No. But I do know that I have 2.1 inch equals 2.54 centimeters. And then what else do I know? 12 inches equals 1 foot. So if I was drawing this out, I would have to use 3 lines because I'm going through 2 different conversions. So that's the same thing here. If I just have a sample of a substance, I don't know how many particles, ions, anything like that is inside of it unless I know how many moles of the substance it has. So the whole reason why the problem we just did with example 2, the whole reason why that problem was set up was to tell us how many moles we had inside of this sample of our potassium hydroxide, because that tells us a lot of things. It's a standard of comparison. So if I have, let's say, 16 donuts, how many dozen donuts do I have? 1.5 dozen. Well, 1/3, something like that. Okay, if I have 18 donuts, I have how many dozens? 1.5, right? So how did you do that? So if you have 18 donuts, let's see, let's make this that. If I have 18 donuts, I know that it takes 12 donuts to equal 1 dozen. So I divide that, I have 1.5 dozen. So it's the exact same thing that I'm doing here with my moles, is I'm dividing in to find how many moles, and it's a comparison that I can use. Okay, so up on top, what we're going to do, whenever you have one of these problems, you're always going to put what you're given the problems, in this case 13.5 grams, C12H22O11, on the upper left-hand corner. Now I need to go from grams to where, according to my molar roadmap? Grams to moles. Moles. And to do that, I divide by the molar mass and multiply by 1 mole. So I put 1 mole C12H22O11 and divide by 342.34 grams C12H22O11. So right now we just did another example 2. Okay, we're in moles. Now we need to figure out how many molecules, because that's what it tells us with the covalent compound, how many molecules we have. So for this part right here, we're going to do, we start at moles, we're going to go over here to molecules. So what number goes on top in my equation over here? Good. Molecules, C12H22O11. And we're going to divide by what? 1 what? Mole, C12H22O11. Alright, so now here's an idiot check to make sure you didn't screw this up. What you want to do is make sure that whenever you label this stuff down here, that all of your units cancel out except for your last box. Alright, make sure you're labeling it in the correct order. Now, you find this number by multiplying everything that's on top and dividing on bottom. So in your problem, what you're going to do is you're going to put in 13.5 in your calculator, multiply that by 6.02, second comma sign, so you're going to little E button, 23. Then you're going to divide that number by 342.34, and then you're going to get your final answer, which is going to be what, guys? Say again. So you end up getting 2.37 times 10 to the 22nd molecules C12H22O11. So you actually get 2.373, but because we only have 3 sig figs in our answer, we just count that off, and whatever is inside this box right here, that is considered a significant figure. So our final answer, 2.37 times 10 to the 22, C12H22O11. So I'm going to cut this off, and then we're going to pick it up with the rest of the example problems.